All right, lesson 9.5, part 3. What happens if we want to solve a quadratic by completing the square when the leading coefficient is something other than 1? This time we have a is equal to -2. What do you think we can do to figure out this situation? Well, yeah, we can absolutely factor out that -2. Let's make the leading coefficient +1. So when we pull out a -2 from each of these three terms, we end up with x squared minus 4x and then plus 9 equals 0. Well, now we can use the division property of equality and we can get rid of that -2. That leads us to x squared minus 4x plus 9 equals to 0. And as we look at this trinomial, we're realizing if we want to solve this by completing the square, we're going to have to go ahead and kick out that 9. So I have x squared minus 4x plus something equals -9, and whatever we add to the left side, we are definitely going to have to add to the right side. So half of b is -2, -2 squared is 4. I have to add a 4 to this side, and I have to add a 4 to this side. The left side of my equation now factors into x minus 2 squared equals -5. Uh-oh, are you seeing what I'm seeing? It's okay. Completing the square is going to help us deal with the fact that we might not have real roots to the solution of this quadratic. So now I have x minus 2 equals plus or minus the square root of -5, and this is an imaginary number. This is an imaginary number. So what does this mean? It means that there are no real roots. We cannot take the square root of a negative number. But we can do this. We can still add 2 to both sides, and imagine this, if you will. X equals 2 plus or minus the square root of -5, and somewhere along the way, I think I've talked about that the square root of -1 is just I. It's an imaginary number. So our answer really, these are some complex roots going on here. Complex roots. And we haven't gotten into complex numbers, but the answer, technically speaking, is x equals 2 plus or minus I rad 5. Right now, you don't need to worry about it too much. The real thing for you to say in this circumstance is that there are no real roots.